this is device integrations and then underscore self-serve. And so depending on the type of integration and sort of everything else, you may have folders. Ideally, we'll have folders where you can keep the MBT file, or there may just be the individual spreadsheets, and all of these are the device integration spreadsheets that were merged over, I think, by Luke, Samir, and Nikhil to the new listener. So I don't know all the details, but basically there's a new listener out there, and by moving over to that one, it allowed us to sort of have this make your own integration. And so I think we could probably take a couple of these as, you know, good examples, and I'll show you what the initial sheet sort of looks like, and I've tweaked it from what tech originally gave us to sort of make things a lot easier for us, in my opinion, just as an AE. And then let's do this one, which was Mike's most recent one.
And, you know, James, just to be clear where these spreadsheets come from, when we do a device integration, right, you're kind of the main point person on the AE side that kind of interprets how the MBT file's put together. And with whoever's putting that MBT file together, you'll kind of interpret that information, put it in a standard template spreadsheet for you and tech to collaborate on, and then that spreadsheet becomes this point of record that we're going to cover right now. Right. So the key takeaway here is the AE team is not creating these spreadsheets and manipulating them or changing them or copying them over, sharing them with customers. This is our internal record keeping that is really maintained by tech and one main AE point person, which is James right now. Make sense? Yep. Cool. Sorry, go ahead, James.
Okay, so if you're starting from scratch, the first thing that you want to go to is this template v2. This is the current version of the starting point. And so you would make a copy of this. You would name it, you know, a device class. I'll show you in a second where you would get this device class. What we've been doing is device class, the type of component, and then the name of it.
And James, sorry to interrupt again. I don't think we need to go through on how you like create the spreadsheet. That's like your knowledge for now, and that's fine. What I do want to cover though is like how do you take an existing device that you're monitoring in the field and understand what the overall process is from that local data to get to the listener. And so we could probably just look at existing device integrations and go through the spreadsheet that way. I don't think we need to create one from scratch.
Okay, yeah. So the easiest thing to do is you make an MBT file in the field. From there, you can paste it into this sheet, which will give us sort of the exact order of the data points. So this is one that Mike just did. And so 0.0 is 0.4 just because there are leading zeros sort of on it. And so what we end up doing in these data sheets is mapping those points to specific base fields that the API uses. This one is just an alarm, a transformer alarm, so there's only messages which are false. In the case of this one, which is, you know, an Eaton power inverter, you can see we're mapping some of these to base field A, which is amperage, and I can show you like the difference here. So this is like my version of the sheet where there's a little bit more information. So you get long names as opposed to just base field names. I'm trying to think of an inverter maybe that we just did.
Why don't you pull up the generic meter, James? That one's pretty common. Everyone's been, I think, using that recently, or at least a version of a meter.
James, can you also compare it with an Alka suite and go to like the framework? I mean, right now you're just showing me points. I don't know what it's referencing to the Aqua Suite.
So that's where this page comes into play. So if you take your Aqua Suite and you literally copy and paste it into this sheet, most of this server side stuff gets filled in, and that's why it's important to like create the MBT first, and then the server side stuff is very easy. Danny, that one's, I don't think gonna work. Maybe this one here.
Let's do this. Why don't you pull up the 735 device class? I know we have a lot of devices that are currently in the field that use that. I think that's device class 5100. So just as kind of a...
It's under this guy.
No, we've been using the 735 for a few sites like the BHE portfolio site that Karan's working on. So yeah, just go to the Google Drive really quick and, just Control F. So this isn't any trick. I mean, for you guys who know where to find the device class, you could just Control F or search in the search bar, whatever your reference is, the device class number. So in this case, 5100. Right? And so here we actually state that the PowerLogic Ion template that we've created shares the device class 5100, which is the same as the meter. So this is actually outdated. So the best thing to do, James, why don't you click on device integrations and go back to self-serve, and then actually Control F here.
Hang on one sec, Danny. I think I'm trying to think, what was the most recent inverter that we did?
I don't know, but let's start with the meter just because it's simpler. Can you Control F and then type in 5100 in the search bar?
So I want to hang on a sec. So let me understand exactly sort of are we trying to understand how this process works, or just
no, we're not
how
trying to
to
understand how the process works, but how to interpret these spreadsheets, as people need to understand how does the listener take data in the field and then map it to the database, and how does that look like in the charting tool?
Okay,
that's most important for this call.
So this is your generic meter map, right? So right here, this is telling you what API base field. So this is the amperage on phase A, amperage on B, amperage on C, phase voltage, line to neutral, phase A, phase B, phase C, phase by phase, A to B, B to C, C to A, right? So this is sort of what the server's seeing, and this side of it is what the Aqua Suite is saying. So for the most part, you can forget float record. The number that's the most important is this number that's in 4 here. These numbers in the brackets are what index that is, right? So if you're looking at Aqua Suite information that's coming in, the information comes in as this order, right? So 0.0 is actually 0.4. So data will come in and it will start as, let's just say 0, 0, 0, and then 1,000 or 100, 100, 100. Right? So this is how the Aqua Suite sends in data. And so even though this is 0.0, it's really 0.4. I know it's weird, but that's just the way it is.
And there's a reason for that, James. I mean, when the Aqua Suite sends us raw data, it's not just the measured data that we see. It's the timestamp comes with that as well. There's a Modbus error code too, and some other metadata. So all the points, the measured points, start at index 4, and everything else that's associated with that device's particular row of data comes before that.
So in the case here, like for this device that Mike just set up, this would be the Aqua Suite packet it would be, let's say, 0, 0, 0, and then 100, 100, 100. So index 4 is 100, index 5 is 100, and index 6 is 100. So we're saying here, oil temp alarm is 4. So when this is sending 100 on 4, that really corresponds to oil level alarm, right? The next one of index 5 is the temperature alarm. So that's also 100 in my terrible example. Same thing for pressure alarm. Index 6 is also 100, right? So in other words...
Quick question.
Yeah.
So the first 3 are zeros because Danny is explaining there's timestamps and whatnot for each packet at point 0. But why wouldn't there be timestamps and whatnot for point 2?
So it may be like
0, 0, 0, 100, 0, 0, 0, 100, right?
So it may be like this, right? So this may be a more realistic example. So the first index is your timestamp, your second index is your error code, and then your third index may be like an AquaSuite status. Those first three...
So the timestamp indicates for all points, not just each individual, not just for point 1.
Correct. It's for that string, basically. So in the next string, it may be, 2009. You may have only the one thing increments, but and sort of so on. So it corresponds to that whole packet, if you will, of info. That's probably the best way to think about it. So all the readings happen on index 4 and above because the first 3 are, let's just say, reserved for other uses. Okay? So in this case, what we're telling the server is the 4th thing that comes in is really your level alarm. The 5th thing the 5th piece of information is really your temperature alarm, and the 6th thing is your pressure alarm. So those correspond to all these, right? So we take another example here. We'll go back to that generic meter map. Right? We can go to here, and what we're saying is on record 4, that's going to be my amperage on phase A, right? So in this example, we may get 2017, 02, 08, and then 139. Well, no, we'll just do 100, I don't know, 101 garbage information, right? And then we'll start and we'll say it's 80 amps, 80 amps, 81 amps. Then we're going to go 208, 208, 208. And then let's just say 480, 480, and 481, right? So the AquaSuite is going to send this bit of information. And what we're doing is we're telling the server when it hits to basically split it up and really assign it like this information, right? So, okay, I'm looking for record 4. That's going to be this. So record 4 for the generic meter is phase A amps. Okay, I'm assigning 80 amps. Number 5 is phase B amps, so 80 amps, phase B, and so on. Does that sort of make sense?
Mm-hmm. Hey, I just put a Slack snippet up of an actual Verislog file, if you guys want to look at that.
Yeah, I see it. First 3 is 0. That's what I was going to mention, James. If you look at that one, the first one looks like time, and the next 3 look like 0, and it looks like the 4th one is the actual point.
Yep.
So, I mean, sorry, the 5th point, not the 4th. And this is what Luke told me last week. He said subtract by 4. So that kind of tells me that the first 4 points should be ignored by us. And the 5th point
it's only the
is that.
first 3, I thought.
I mean, we're getting a little size. You don't need to know all that. All you need to know is in the AquaSuite, when you see a point value, it starts at point 0. That point 0 equates to record 4 in the spreadsheet. That's all we need to know for the purpose of this call.
So offset of 4. Okay.
Yeah.
So Mike, I like the real life example, so I'm going to just roll with that for 1 second, right? So this is a Veris E51 is 48, but now we need to figure out, did they actually migrate that? They had to have. $48. Yeah, cool. Cool. So now we can see this in real life. And I hate text naming convention. That's fine. Okay, so data mappings, right? Cool. So let's decipher this one here. Okay, so you can see, besides the fact that these are out of order, which makes things oh so much fun, we're going to put them in order. Right, so it's going to be, this looks like number 4's first. Then we have number 5, number 6, number 7, and we'll stop there because everything else is sort of irrelevant, but we can go with that. All right, so in the first example here, right, so I'm looking at the timestamp 2014. Let me move this up so you guys can see. Okay, so 2014 922, right? That's index. We'll say, I don't think actually the timestamp counts as one, so maybe that's the difference. So let's say 000 are our first 3, and then the fourth one is this 18.8, right? So that's watt hours. Now, there's a little bit extra piece of the equation here, which is the watt hours are times 1,000 because we deal with watts and not kilowatts. So we actually take this 18,855 and multiply it by 1,000, but this becomes our watt hours. In the next one, this is our total watt hours imported, is the 21.9, right? We go to the next one, 3050 is total watt hours exported. And then the next one is, looks like we got a little bit of math here, which is kind of cool. So we actually are doing this value, right, the 7th, plus this value, and then multiplying those two together to get the K-bar imported. Is this starting to make sense a little bit, or am I still?
No, it makes sense. Yeah.
Okay. So, I mean, I think the most important thing to realize is there's no sort of right way to make the MBT or the template. It's just that everything has to line up. So if for whatever reason you like to put, you know, some values in front of the others, as long as this matches the server-side integration, it will be correct. Now, I think Danny and Prerit want to sort of standardize on an approach of like, we'll put all amperage first, all voltage next, power after that, and so on, which should make things a little bit easier going forward. But really, this document acts as your translation of these log files.
Forgot what you were doing
James.
at the beginning. You were copying.
Say it again, Karan. I'm sorry, you got cut off.
Yeah, Karan, breaking up a bit.
Oh, sorry. Can you guys hear me?
Yeah.
Yeah.
Okay. Is this the sheet that you copied in the beginning, template 2?
Yeah, so it looks a little different.
Yeah, and Karan, don't just ignore template 2. Don't copy anything. Don't edit anything. You were just reading the value of the spreadsheet, and that's why you can Control F. If you don't know exactly what the name is, the best way to look it up is by the device class. So once you're in the self-serve folder, just try this really quickly, James, just as an example. Just do Control F. Don't go into the search bar, just Control F here within this page and type in 5100. And there's your device. So every single device class, even though the naming isn't quite that standard, should have the number of the framework like file. So when you have an MBT file, you always have that device class. That is how the listener interprets the data, and this is how, this is the record that explains what the listener is doing. So from there, you always go to data mappings to understand which values are being mapped to which base fields. And sometimes there's additional scaling, right? So you'll take note of that scaling. Sometimes there's math. So you can look at all of that here. And just in case you don't know what a base field means, these are meant to be short names that you can easily interpret. But in case it's not clear, I believe you can also go to the data validation tab. James? If you click on data validation, I believe most of these base fields are explained nicely there. Where you have a long description that you'll be more familiar with. So there's the base field, there's the long name. The long name is what it's called in Charting Tool and in the reporting UI. So that's a good reference for you guys to have when you're trying to look through the data mappings index or reference table. Does that make sense?
Yep.
And in most cases, it's one-to-one. One index will be used for a particular base field, but sometimes there's additions. For AC energy in particular, there's logic to look at a particular index value or register on the Aqua Suite and then take the difference every 5 minutes. That's how we get that nice curve, and it's not just like a constant graph going up. So just keep that in mind. For certain base fields, there's additional math involved, but most of the time you just look at what is in this data mappings columns, and it'll tell you which registers go to which names in the platform.
Okay.
Okay. Great. Any other topics on listener stuff? James, I know we're kind of looking at both ends of the puzzle, and eventually we'll get some tools maybe to look in between if we ever need to. Just so you guys know, if you ever kind of question the data that's coming through to the listener, you can ask tech for the logs, which you will not be able to interpret probably right now, but it will be something I'd like to work on with you guys in the future so that you can look at some of this yourself. But for the time being, it should be pretty straightforward. You look on the Aqua Suite, you look at the point values, and then you look at this data mappings ID if you really want a sanity check to know what's going into the database.
Hey, Danny, can we? I'm thinking the reason you guys are showing us this is just so that we could answer any questions sales guys or clients have, right? So can we go back to the 735 really quick?
Sure. And James, if we have time after this, I'm also thinking let's talk about faults a little bit. In particular with the relays, I think that'll be helpful. So I'll let you cover both of those topics.
So this is 735 right here.
Yep. Yeah. So this is the 735. Karan, if you pull up, so James, go ahead and in EOD, let's pull up a site that has the 735 template that we're working on.
Do we just need a 735 template, or you need it like active?
Let's look at a live data really quick. In EOD, go ahead and search Bedart. This is actually a question that just came through from Brendan. So just go to sim status and then search BIDART.
EOD has been really slow this afternoon.
Actually, it's an apps engineering escalation channel if you want to just pull it up there. Escalation. Yep. So just pull up the Aqua Suite on that IP. Mm-hmm. Carly 1020. All right. And so here, if we wanted to just click on the meter, I mean, we already know it's device class 5100. I don't think we need to cover how to find that out. And you just put that on one side and look at the spreadsheet on the other side. This is a pretty common point of confusion, guys, because this particular meter has import and export received and delivered, and in the PV field this can be very confusing for some people. So just to kind of start from the top, you can see that 0.0 is current A, that's 614 amps, right? And you just follow from there. In this case, it's fairly straightforward. We're not skipping any values.
I think we skip current. I think we skip current neutral.
Oh, okay. All right. Well, yeah. I mean, do we hide anything here, James?
No.
Oh, I'm just getting confused because we're jumping around here. Okay,
I'm trying to get these in order because when Tech did these integrations, they like sorted it by the base field names instead of just doing it like a normal person.
Okay.
So I'm trying to make it like that when you read the Aqua Suite, it actually reads out normally here, but...
Okay, got it. So in any case, I mean, one of the examples that's very common is people want to know, like, how are you mapping energy, right? Because for us, phase by phase, power phase by phase, current, it's easy to look on the Aqua Suite, and that value actually is translated very transparently to the listener in the charting tool. But let's say we want to understand where does energy come from, right? And right now you can see that energy is base field watt hours at the bottom of the list, at least at the moment while James is working. So James, once you move energy, why don't you just leave it there for a minute? Okay, yeah. Cool. So for energy, it's record 26. So if we look at the Aqua Suite and we subtract by 4, we can see that that record is actually 22, energy delivered. So in this case, you know, it's clear there's something screwed up here. You can tell already, and it's because the power values are so low. In any case, that's not what the issue is on site, but just to show you, this is 67 kWh. That's what's being mapped to watt hours. And if you look further down, that's also what's being used for total watt hours exported, TOTWHEXP. Of course, we're applying a scaling factor for both of those of 1,000. So the values, why are we doing 1,000?
Because it's kilowatts to watts.
Oh, yes. So these are in watts. So everything's being multiplied by 1,000, and you can see that there's a modifier type that I think James wanted to highlight previously. So watt hours is doing cumulative values, which is exactly by, you know, taking timestamps every 5 minutes or every hour, and then taking the difference of those to calculate watt hours. So if we plot this in the charting tool, if you wanted to bring it up, James, really quick, and go to the charting tool for Conergy.
Oh, Conergy commercial, right?
Yeah, sorry, forgot. I do that too.
Which one is it?
So yeah, all three of these.
So it's going to be BIDART, B-I-D.
Is it north or south?
Let's check to see which one has super low readings.
Not that one. This one.
Okay. So these are tiny. Let's plot, yep, KWH, and let's plot export and import. And the scales are going to get all screwed up, but we just want to hover and see what it looks like anyway. So you guys can kind of see at this scale that total export reel is going up and total import reel is staying flat. And if you actually look at the latest reading here, it's going to be a little old, but why don't you hover over the latest reading? We have export is 67 kilowatt hours and import is 71 kilowatt hours. And if we go back to the spreadsheet that James had for this device integration, we can see that total export is record 26, which would be 22, and import would be 23. So if we do another window, James, for the Aqua Suite, we'll see that those values actually match up very closely, if not almost the same. So there's 67 and there's 71 for export and import. So it can get a little confusing, especially when we have these names and they're different from the platform names. That's probably something we're going to improve just for full clarity. Because import, export, delivered, received, especially with these line and load calculations, gets really confusing because everyone does it differently. So we need to be all on the same page on our standard. But in any case, you guys can see exactly how this kind of translates through the system and how we have documentation for all of this. It's just not very, client or sales facing, but we should at least know how this works. Does that make sense to everybody?
It does.
So one last thing I want to do is just give sort of like a real world example, I guess. So does anyone know a site that has a lift on it? Are there any Connergy sites that have lifts?
No.
No.
Do you have any BHC sites with lifts that you want to maybe put on there? They have lifts. Why don't you go to Euroliker, James?
Hey, I'm gonna go with Radiance. Oh, Radiance, not
Okay.
Radiant.
But Mike and Colin, does this make sense to you guys so far? Mike, I know we went through it once. I think I went through it with you, Colin, too, but I just want to make sure we went through it again.
Yeah, I mean,
any questions up to this point?
it's a good refresher. I would be comfortable if we talked about scaling and where that happens. I know we scale watt hours and stuff, but do we have rules going forward where we're doing all the rest of the scaling at the Aqua Suite?
Yeah, so the rule going forward is, with the exception of kilowatts, which the listener actually does one, and it will actually convert it to watts in the database and then convert it back to kilowatts. We want everything in SI units. So that means volts, current, not milliamps or kiloamps. Everything should be in standard SI units. And it'll just make things a lot easier.
Right. So, I mean, the reason I bring this up, just a little history lesson, guys. Before the AEs were doing this stuff, it was done by Keck, especially very early on. So, there are some devices out there. If you ever look at like an IMT reference cell in the field, the values look like crap because we're doing all the scaling at the listener.
And I would say, like, to Mike's point, the device, hopefully this doesn't happen too often, but in the case of like weather gear, it could happen quite frequently. The device can report to us in miles per hour instead of meters per second. It could report to us in Fahrenheit instead of Celsius. Our job to make things easy is to make the AquaSuite page look as standard as possible, and that means the name should be to a standard that match what the listener and what our platform says. And the units should reflect that as well. So if it is reported in Fahrenheit by the device, we, especially now since the AquaSuite already has arithmetic built in, and it has even more now, we can actually do some front-end engineering to make everybody's life easier and scale it locally, because that's just going to make everything easier in terms of checking and QA across a particular site. So these standards are not written up anywhere right now. We should probably write them up, but just so everyone's aware of what the philosophy is, that'll make a lot more sense if you guys start to see this on existing sites, and if you guys get, volunteer to do device integrations, you'll kind of understand what we're trying to aim for.
All right, I think this is probably the last thing here, but sort of a real world example of when this is useful. So it was not this client, but I just pulled up a Luft to sort of show you guys. A client, like, we had a storm here in Jersey, and the client's in New Jersey, and they were looking at their Luft, and they said, hey, we're getting 30-mile-an-hour winds, and my $2,000 Met station isn't recording 30-mile-an-hour winds. What the hell's going on? So if you look, first of all, wind speed on the Luft is plotted in meters per second, right? So you could easily just punch that into Google and say, like, hey, what is 2.3 meters per second in miles per hour? So maybe that's where the customer is sort of like not understanding that there's some conversion. And then it's like, okay, well, that's only 5 miles an hour. That's not quite right. So if you go to the integration sheet, you can see wind speed is, the record is index 39, right? So if we pull up an AquaSuite and the Luft, and we go to 39 minus 4. 39 minus 4 is 0.35. So you can see that we're actually plotting the wind speed average and not the wind speed, let's say, actual, minimum, maximum, any of those. So we're actually plotting this average. If you look in the Luft documentation, that averages over the last like 10 minutes. So it's sort of a better idea for solar, because you're sort of looking at wind as for a cooling effect and not just like a weather station out there of like, Weather Underground or weather.com. So that's one of the ways that I've used this sort of reverse lookup of how is the integration actually calculating things.
Thank you, James.
Yep.
One more thing I just want to mention before I forget. Can we cover faults like really quickly? Because I think that's going to be helpful for the guys, especially with new device integrations for inverters and for relays. How do we know how to interpret fault data on the AquaSuite and make that something that happens on the front-end platform? At a high level.
So
how do we look that up?
Basically, faults get mapped to another index, just the same as data points do. So in the case of this one that Mike did, right, there are only faults on this one. And so those come in at, record 4, record 5, and record 6. And so there's another tab here under message definitions where you can specify if index 4 has a value of 1, this is going to be the fault that's shown, the short description, the long description, and what priority it is. Same thing with 5 and with 6. So this one's a little boring, but it's a transformer alarm. And if we go to a power electronics inverter, this one probably has a little bit better, or more faults, I should say. Come on. We go to message
Faults
definitions here. So you can see it looks like all right, Argo, I know, buddy. Index 18, these are in bits, but bit 0 is going to display online, contactor, all these different fault descriptions. And if you go to data mappings and you look at index 18, hey, stop. You can see status here. So this hasn't been finalized, that's why. This is the 1500. Where was the regular power electronics? Oh, we can do this one.
This one is nasty. This is a good fault inverter.
I don't like this one because this is an old school way of that they message identified. But anyway, if index inverter status 1 has a value of like 13, it's going to just display this. So if you look for inverter status 1 on your data mapping, you can see here inverter status 1. Right, and if it has a value of 13, it would show this. So on the Aqua Suite, for index, what is this? It looks like index 4, the first one, is your fault index. If that comes through with a value of 13, then this is what's going to be mapped on the front end, like on the charting tool and everywhere else.
Yep, and James, there's kind of like two ways to represent faults in the Aqua Suite and for the listener to interpret them. One is integers and one is bits. Does everybody on the team kind of know the difference there?
Yes, bits are hard, integers are easy.
I would say Kinda is a good description of my understanding right now. Kinda.
Yeah, so we can probably do another training on bits versus integers. The short and sweet version is integers are the actual values that you see on the Aqua Suite. So if you see an integer mapping, it means if the Aqua Suite shows 10 and the mapping says 10, that fault will be represented. For bits, it's a little bit more complicated than that. The value of bits is you can have multiple faults in a particular register, whereas with the status, it's either 10 or it's 9 or it's 8. With bits, you can actually have superimposed statuses. And pretty much what it comes down to is a bit of 0 means that the Aqua Suite will have a value of 1 as part of the summation of that register. If the bit is 1, the Aqua Suite will add 2. So it's pretty much everything to the power of 2. So bit 0 is 1, bit 1 is 2, bit 2 is 4, and if you guys are following along, what that means is if you have bits 0, 1, and 2 all up, the Aqua Suite will actually show a value of 5. I'm sorry, 0, 1, and 2 would be 3. So you're adding 0 plus 1 plus 2. I'm sorry, you're adding you're adding 1 plus 2 plus 4, so it would be 7, in fact. Does that make sense to everybody? I'm guessing the silence means no.
Guys, I've been doing the device integrations and it still doesn't make sense to me. So,
hey James, can you give me presentation status again really quickly? Maybe I'll
Yeah,
just
hang
request
on
it.
one sec. Yeah.
Or, yeah.
Yeah. I think you just took
Alright.
it back, right?
Yeah, I think so. Can you guys see my screen?
Yep.
All right, so it's actually not too hard, but it does take a visual aid. So just for 5 minutes. So a bit in a Modbus map will say, okay, bad, good. This is the fault. This is the bit. Bad, good, okay. Let's say it's that simple. The bit will be starting at 0, usually go 1, 2, 3, and depending on the type of register, you can have a lot of bits, but let's just say we only have 3 bits for now. And usually it's actually 1 and 2. And this is the actual equivalent value of that bit. So it's actually 2 to the 0, which is 1. And if you copy that down, it'll be 2 and 4. Okay, so if bit of associated with bad is up, that means this bit is asserted, which means the Aqua Suite will have a value of 1 added to that register. If this is only up, the value will be 1. If this is only up, the value will be 2. If this is only up, the value will be 4. If all of these bits are up, you just sum the bits that are up. You don't do the summing, but the Aqua Suite automatically does. So that means that your value on the Aqua Suite register will be 7, and Tech will have the listener capability of breaking that down and saying, okay, if the value of the Aqua Suite is 7, that means all of these bits are in the up position, so I should show all of these faults. Does that make sense?
Mm-hmm.
Okay, so the beauty of that is you can have more than one fault per register, whereas with the status, I'm sorry, more than one fault up at the same time, whereas with this, you're usually okay, good, or bad. You're not all 3 at the same time. And usually, like, it won't be bad, good, okay for bits. It'll be like fan fault, overcurrent, and maybe ground fault. Because who knows, like the inverter could be really screwed up and actually has all those issues. And so you're able to superimpose all these statuses in one number. And rather than saying, oh, just add these values, you know, in the Modbus documentation, it's always referred to as bits. But it's just 2 to the bit. It gives you the value that you add to the register. Okay? So, I mean, that's getting a little bit into the weeds, but you know, that will probably help you at some point in the future, especially if you're doing device integrations for inverters and you're working with James. You guys will probably come across this very confusing topic of fault bits versus fault statuses and trying to figure out which one the inverter manufacturer actually means. And equivalently for relays as well, which I think we don't need to cover right now, but it's the same exact concept. You need to understand, is the listener looking for an integer or is it looking for a bit for a certain status or fault? Any questions on that? Okay.
Oh, makes a lot more sense after we change the names from good, bad, and okay.
Right. Yeah. There you go. So, great. Well, James, was there anything else you wanted to cover?
No, I think that's it.
Cool. All right. Well, guys, thank you so much. I'll let you go back to your normal lives, and feel free to follow up with any questions in Apps Engineering General. I'm going to post this video to our YouTube link channel and send the link to you guys in case you want to review later on. But it'll be up on YouTube for posterity, internally, of course. Okay.
Well,
Thanks, James.
Thanks. Bye.
Thanks, guys. Bye.
Bye, guys.